Apache Kafka is known for its high throughput and low latency, making it a popular choice for building real-time data pipelines and event streaming applications. Several factors contribute to Kafka's speed and performance. Distributed architecture. Kafka is designed as a distributed system, allowing it to scale horizontally by adding more servers, brokers, to the cluster. This architecture enables Kafka to handle a large volume of data and distribute the load across multiple nodes. Partitioning. Kafka topics are divided into partitions, and each partition can be distributed across different brokers. This allows Kafka to parallelize read and write operations, enabling high throughput. Replication. Kafka supports data replication across multiple brokers. Each partition can have one or more replicas, providing fault tolerance and high availability. Replicas can be used to serve read requests, reducing latency. Batching and compression. Kafka can efficiently handle large amounts of data by batching messages together before writing them to disk. Additionally, Kafka supports message compression, which reduces the amount of data transferred between producers and brokers, and between brokers and consumers. Zero copy. Kafka uses a zero-copy approach, where data is read from or written to memory buffers without being copied between kernel and user space. This reduces CPU usage and improves overall performance. Log data structure. Kafka storage is organized as an append-only log. This sequential write pattern is highly efficient for both disk and memory, making it suitable for high-speed data ingestion. Async and non-blocking I/O. Kafka utilizes asynchronous and non-blocking I/O operations, allowing multiple operations to be performed concurrently without waiting for each operation to complete. This enhances efficiency and responsiveness. Highly optimized codebase. Kafka is implemented in Java and is optimized for performance. It leverages various performance optimizations and tuning options to make the most of the underlying hardware. Efficient metadata management. Kafka maintains metadata about topics, partitions, and brokers in a distributed manner. This metadata management is optimized for quick access and minimal overhead. Customizable retention policies. Kafka allows data retention policies to be set per topic, so older data can be automatically removed based on time or size. This helps manage storage costs and improves overall performance. Tuning and configuration. Kafka provides a wide range of configuration options that allow users to fine-tune the system to match their specific requirements and hardware capabilities. Community contributions. The open-source nature of Kafka has led to a large community of contributors who continuously work to improve its performance, scalability, and reliability. Keep in mind that while Kafka offers high performance, achieving the best results often involves careful consideration of factors such as hardware, network configuration, partitioning strategy, replication settings, and consumer design.